In this lesson, we are going to talk about product of vectors. Our goal is introducing dot product, cross product, and scalar product. In our first lesson about vectors, we use an arrow to show a directed line to represent a vector. Two vectors are equal when they have the same size, parallel, and same direction. If they have the same size, parallel, in opposite direction, we call them opposite. V is opposite of U, and we use V equals negative U or U equals negative V. Opposite of a vector is the vector itself. We define the angle between two vectors. We put two vectors in tail-to-tail position. The angle between U and V is the smallest rotation that puts U and V in counterclockwise direction. To add two vectors, we use tail to head position. The addition of two vectors is a vector. The tail of the vector is the tail of the first one, and head of the vector is the head of the second one. For subtraction of two vectors, there should be tail to tail, and tail of U minus V is head of V, and head of U minus V is head of U. We used cosine law and found the magnitude of U plus V and U minus V in terms of magnitude of U and V and the angle between them. In this lesson, we work on scalar product when we multiply a number by a vector, dot product when the result of multiplying two vectors is a number, and cross product when the result of multiplication of two vectors is a vector. Scalar product. Let's assume M is a number and U is a vector. MU is called scalar product of M and U. By definition, MU is a vector parallel to U. Magnitude of MU is absolute value of M times magnitude of U. If M is positive, MU and U have the same direction. If M is negative, the direction of MU is opposite of the direction of U. 0 times any vector is 0 vector. Therefore, if M is 0, the result would be 0 vector. For example, U is given in this diagram. 2U is a vector parallel to U, and its size is double the size of U. Therefore, if size of U is 1, size of 2U is 2. Negative half of U is a vector in opposite direction of U, and the size of that is negative 1 over 2. The important point here is MU and U are always positive. Dot product. Dot product of two vectors is a number. Dot product is denoted by this notation, U dot V, which is the same as size of U, size of V, cosine of alpha by definition. when u and v are non-zero vectors and u is perpendicular to v, u dot v is 0. If we rearrange the equation, we get cosine of alpha is u dot v over size of u, size of v. Cross product of two vectors. It's denoted by u cross v, this notation. It's a vector. U cross v is perpendicular to both u and v. Therefore, u dot u cross v is 0. U cross v is perpendicular to u. V dot u cross v is also 0. Size of u cross v is the area of the parallelogram built on u and v. So it is perpendicular to u and v, and its size is the area of the parallelogram built on u and v. And its direction is coming from right-hand side rule. That means if we are pointing our fingers pointing from u to v, our thumbs shows the direction of u cross v. U cross v and v cross u are opposite of each other, because if you use right-hand side rule, one of them is out of the plane containing u and v, and the other one is into the plane. They are in opposite direction, but they have the same size. Size of both of them is the area of the parallelogram. If u and v are parallel, then u cross v is 0. We know area of a parallelogram is base times height. If we assume one vector, one side is on vector u and the other one is vector v, then base would be size of u and height would be size of v sine of alpha, if we use definition of size in this triangle. Therefore, the area of the parallelogram is size of u, size of v, absolute value of the angle between two vectors. In other words, size of u cross v is size of u, size of v, absolute value of sine of the angle between two vectors. By definition, u dot v cross w is called triple product of the vectors. Let's have a couple of examples. Assume u is a vector with size of 5 and its direction is northeast. Therefore, 2u is a vector with size of 10, same direction. Minus 3u is a vector with size of 15 in opposite direction. Opposite of northeast is southwest. Therefore, direction of negative 3u is southwest. Notice that magnitude of mu is absolute value of m magnitude of u. Next example, u and v are two vectors. Size of u is 5, size of v is 2, and the angle between them is 30 degrees. Here you're looking for u dot v and magnitude of u cross v. U dot v is magnitude of u, magnitude of v, cosine of the angle between them. 5 times 2 times cosine of 30 degrees, 5 root 3. And magnitude of u cross v is magnitude of u, magnitude of v, sine of the angle between them. absolute value of the sine of the angle between them, which is 5. Our next example is a proof. Proof if u and v are two vectors, u dot v to the power of 2 plus magnitude of u cross v to the power of 2 is magnitude of u to the power of 2 times magnitude of v to the power of 2. We know u dot v is size of u, size of v, cosine of alpha, u cross v is size of u, size of v, absolute value of sine of alpha. If we expand these two terms and factor size of u to the power of 2, size of v to the power of 2, we have size of u to the power of 2, size of v to the power of 2, cosine squared of alpha plus sine squared alpha. Since sine squared plus cosine squared is always 1, left side and right side are equal. There are some properties of addition and dot product, cross product. I briefly go over them as examples and try to prove some of them. First of all, u plus v and v plus u are equal. The addition of vectors are commutative. U plus v, if u and v are two vectors, and v plus u, if we draw u plus v in each diagram, we see they are parallel, same direction, and same size. Therefore, they are equal. Addition of three vectors is associative. U plus v plus w is u plus v, the result, plus w. This can be proved by a diagram too, geometrically. U plus 0, 0 plus u, and u are always the same. U plus minus u is always 0. U minus v and u plus minus v are exactly the same thing. U dot v, v dot u are the same. U cross v and v cross u are not the same. Dot product and cross product have distributive law on the addition. U dot 0 is number 0. U cross 0 is vector 0. If u and v are parallel, as we said, the cross product is 0. U dot v over size of u, size of v is cosine of the angle between two vectors. Therefore, u dot v over size of u, size of v is always between 1 and negative 1. This is equivalent to saying absolute value of u dot v is smaller or equal than size of u, size of v. There are two more properties. A and b are two numbers. Au dot bv or au cross bv is ab times u dot v or ab times u cross v. We are using these properties a lot, and in next lecture I'm going to prove a couple of those. Let's recap. In this lesson, we talk about the scalar product when we times a number by a vector, which is a number. Dot product, which is a vector, because scalar product of an is a vector. When you times a number by a vector, we get a vector. Dot product of two vectors is a number. Cross product of two vectors is a vector perpendicular to both vectors, and its size is the area of the parallelogram building on u and v, and its direction is coming from the left-hand side rule. Thanks for watching.